All right, welcome. Thank you for coming to my talk called TypeScript for C++ Programmers. That's my name. And that's my face. So my name is Ólafur Waage. I am a senior software developer at TurtleSec AS. And if you'd like to yell at me on Twitter or tell me dad jokes, you can do that too. It's apparently very popular and fun, so you can try that. Cool. I work for a company called TurtleSec, recently moved here from Sweden. I did a 7-year stint in the gaming industry before, which was a lot of fun. I broke a lot of servers. Fun times. But yeah, I work for TurtleSec. We are a consultancy and training company. So if you would like training, like there was here earlier this week, you can also yell at us on all sorts of media or visit our website. Good stuff. So let's start with a quote from a famous philosopher. You can't always stay in your corner waiting for others to come to you. You sometimes have to go to them. That's Winnie the Pooh. Good. So, what this talk is and what this talk isn't. Going over a language requires a lot of items to be covered. That's going to be things that I miss. So, not everything is going to be covered in detail. So, this is more of a comprehensive overview. Well, this is not a comprehensive overview of the language. This is more like a curious look of this specific world. I wrote this kind of as a point of view from a C++ programmer because I am a C++ programmer. So, but anyone not familiar with this world can benefit from this talk in some way. Cool. Or as I would sometimes say, this talk is like this. So what are they doing over there in that other world? I'm here in my binary world. So let's have a fun look over the snowbank. All right? Ready for that? Yes, thumbs up, good stuff. Let's start with the history of everything. No, okay, no. Mostly everything. No, mostly JavaScript. So it all started with the World Wide Web, or it started with Netscape. So Netscape added JavaScript in 1995. Who remembers this logo and the animation and all of the 256 colors? Great stuff. We almost got Java or Scheme. That was the thing. It would have been fun to have Scheme, right? I get a lot of nods in the audience. They all want Scheme. Then we get ECMAScript in 1997. They took 2 years to standardize this stuff. Yeah, let's think about that. So that serves as the JavaScript standard. There are other languages which base on ECMAScript, like ActionScript, if you did Flash programming. But yeah, that is the JavaScript standard. So this is a standards-backed language. And then it's all Google's fault. Well, not in that bad way, but it's all Google's fault because in 2008, we have the Chromium project. And then they add V8 as a JavaScript engine or compiler or thingamabob. This made the language much more performant. So this was a big thing with JavaScript back then. It was very, very slow. And the implementations were also very different. So you can think of this as a standardization of the standardization. Maybe not. So I don't like the World Wide Web. It has too many funny cat pictures. So can we do this offline? And yes. Project called Node.js introduced in 2009, and simply put, they took the V8 engine and allowed you to just run code in the command line or wherever you want. So there's more to it, but that's kind of the idea. And this stack is then becoming more full, if you know that reference. And then we have the library of JavaScript. We get NPM. That's in a year later, 2010. NPM as a package manager. So this is for libraries that are designed to run within the Node.js ecosystem. That's kind of the idea in the beginning. So you have now the world at your fingertips, and you have a 20 gigabyte folder with the internet. Good stuff. So this is a good foundation. Well, this is a foundation, right? So now we have these projects were kind of making the basis of a JavaScript development environment. So if you were a JavaScript developer, these were the tools. There are other tools probably someone will yell at me for, instead of saying npm, they should say yarn or some other tools, but the idea here is the same. So this is kind of the, if you go to work in the morning, you had these things in your hands. But JavaScript is not perfect, unlike C++. No, I kid. So we have this environment, and a lot of people are starting to build all sorts of cool things with only JavaScript. Writing servers, writing games, yeah, great stuff. The language has its flaws. There's a famous talk called What, which is a lightning talk about problems in the language. And as far as back as 2002, we had static analysis tools for JavaScript to catch these common issues. JavaScript's type system is dynamic. There are underlying primitives, but and the almighty JSON object, which is where that comes from. It's a JavaScript object notation. That's where that comes from. So before we go into TypeScript, we need to have a talk. We need to have a talk about JavaScript because this gives us a sense of why TypeScript is there in the first place. All right? This will give you some context for the talk going forward, and then I will change gears into only TypeScript after that. Good. We need to start with the hello world, right? But I also have some examples. I can make a variable, number 1 or number 2, have some numbers to it. They can even be floating point. I can have some text, and I can have a Boolean, and no type definition is needed. And I can print them out, and things work as expected. Good. We're happy. I can make an object. This is a JavaScript object notation, even though, so JavaScript looks like this, but you have to have the quotes around the key. So I have Anna, she's 25, and she has graduated. Great. And if I print that out, I get that wonderful output. So this, I'm going to talk about this a lot as an object. That's usually called an object. So if you have a curly brace, and then you have key colon something, so these are called objects. That's usually the idea. All right, so let's do a simple example, or not so simple example. We're going to have a loop, going to go from 0 to 10, and then I'm going to sum up the values, and I'm also going to store I and j just for fun, because who wouldn't? So if I print out sum, we get as expected, right? Any other problems that are going to happen here? Probably some JavaScript people here like, yep, because you can print out I. That's totally fine. There's one more. You can print out j. Because JavaScript has a thing called hoisting, where variables are hoisted up to the topmost scope. There are probably some technical details to it, but it will end up in things like this. So not great, but hey, here we are. And I can also make an anonymous function. I just say function, have the arguments, and then some scope in it. I'm going to loop on 3 times, and I'm going to call this function after 100 milliseconds each. So I'm sending I in, which is from the argument, and I get 3 every time. Because the I is hoisted out, the value is set, and then when the function is actually called, I'm using the out hoisted I and print it out. So then that makes sense. So that's fixed with changing 3 letters. I changed it to a let instead of a var. So when I make a variable with a let, it behaves more like we are used to. So scoping makes a little bit more sense here. Good. I can even make a variable. I can even make it const. And this is another notation for a function that I will use sometimes. I call these arrow functions. So I have the arguments and the arrow, and then the body of the function. That's usually handy. And I can make that into a variable, const it, send it in, and we're happy. That's all okay. Good. So then I have an object. I'm going to have a value of 10 in the object. And then I can also put functions into the object. So here I'm printing out this.value. So what do you think happens when I print this out? Any takers? 10, someone said. No. Yes, we get 10. So we're happy here, right? But what happens here when I have an arrow function as one of those members? Looks the same otherwise, but it doesn't work. It doesn't work, and I'll show you why it doesn't work in a bit. Because there is a quirk happening here. Okay, so we have a language. Language has quirks, but of course, if you know a language and you know the quirks, like we do with C++, it's fine. We step aside from the quirks. We tell people, please don't use those quirks or be careful. All right, so many had looked at the JavaScript problem and tried to solve it by creating a new language. TypeScript looked at this problem by becoming a strict superset of JavaScript. So all JavaScript is legal TypeScript, straight through. You can just take the JavaScript, copy paste, run it through TypeScript. That's fine. TypeScript is then compiled into JavaScript, and at the runtime, JavaScript doesn't exist. In the same way in C++, at runtime, there is no C++. There is just assembly. Cool. So let's install TypeScript. We can actually use the Node.js installer. You can install it in a similar way on the command line. The command line is a bit more trickier, and there are other ways, but this is kind of the easiest way to show you. There are also the tools, and again, there are quirks within the installation, but this is a way to get Node in. And when you get Node installed, you also get the npm installed. And then I run this. I go into my project folder, I call npm init, go through the arguments there. I install TypeScript. I call save dev. You'll see why in a bit. And because I do a save dev, TypeScript is not installed globally in my system. TypeScript is installed in my project folder within this node modules folder that people talk about. And because it's in the node modules folder, I can run it by saying npx and then tsc. tsc is the TypeScript compiler. And I can say init to make a TypeScript project. So that's the only thing. The npx means just run an application within my project. If I would have installed it globally by npm install -g, I could have just said tsc. That would be the same. So it looks like this. I have my node module folder. I had some code written. I will then get two files, package.json and tsconfig.json. So let's look at them. Package.json looks like this. And that's for the npm. npm will give you package.json. This is my talk. This is my project. Main file is index. And you can see the dependencies. So I have two types of dependencies. You have a developer dependency, then you have a dependency. So this is what you need to make the project, and this is what you need to run the project, right? And then we get this file. This is tsconfig. Yes, I made it like this for fun, but what this is these are all the compiler flags that you can set for TypeScript. So there's like 3 or 4 of them enabled, and they have comment next to each one of them. But that was more for fun, but it is here. So these are the settings that I will run with the compiler. So I make index ts, hello world, and then I would like to run TypeScript. I say npx tsc, good stuff, and I get the same thing out, basically. There's a thing called strict mode in JavaScript. I'm not going to go into what that means, but strict mode good. That's kind of the explanation of that. So yeah, so you can see that these are basically the same thing. And there's so much the same thing that I can, if I run them through Node, Node.js, and I say Node index or TypeScript, it doesn't matter, they're the same file. I'm going to do this one more time just to show you, but I'm running the JavaScript file, which is outputted. It gives me hello world, and I can actually run the TypeScript file as well. But generally, this isn't done because TypeScript is not valid JavaScript, but we can have some fun here. All right? So let's look back at our example, the thing that didn't work. So now, if I put that into a TypeScript file, I will get an error, and it will tell me that the containing arrow function captures the global value of this. Yeah, because in this object setup, this in an arrow function is the global arrow function. In a function, it's not, because it's within that context. So that's a quirk of JavaScript. All right, which is, we don't want this. We don't want this behavior. And this actually, we'll get 2 errors, because it will say that, like, hey, this is not maybe the this that you want. And also, value doesn't exist within the global scope. So there's 2 errors, actually. All right. And there are no quick fixes available. Good stuff. But here's another thing. I can compile this. We have an error. I will get an error out. I'll get both of them. So from our point of view, this is bad. But I can still run it. I can say node index.js. It runs the same behavior, tenant undefined. I can even run a TypeScript file. It's tenant undefined. What gives? Well, we still get a JavaScript file out because maybe you wanted this behavior. And there are ways to say to the TypeScript compiler, no, when it fails, I don't want an output file. But by default, it actually gives you this. And now you can actually see the quirk that's happening. They make a variable called underscore this in the global scope. And then that is the variable being used in the arrow function. And you can see the arrow function isn't there anymore. It's just a normal function now. So they've captured the quirk. So you actually get the quirk out through the TypeScript. So yeah, fun. So let's shift the focus to TypeScript and the language itself. Some of these features come from or are based on JavaScript, and going like back and forth actually will take more time. So it's just easier to think of this as TypeScript. Some of these things might come from JavaScript, but let's focus on it as TypeScript. So it was released in 2012, developed by Microsoft. The idea of, like I mentioned before, to add type safety to JavaScript, but also have existing JavaScript application be valid TypeScript applications. And later on, we'll show that you can actually get type safety on existing JavaScript applications. So they're compiled into JavaScript files, and the language also has a language server, which is installed in VS Code, for example. That's what gives you syntax highlighting and error checking. And you can actually just ask the language server itself and give it some JSON and it will reply to you. That's pretty neat. All right, functions. Here we have a function. So here you see that I'm taking two arguments and the type after it. So it's colon and then the type. And this function then also returns, you say then colon and then the type after that. And then I should say return a plus b. So now, if you imagine this as JavaScript, it would be the same if you would remove colon number from both of them. That would be exactly like JavaScript. So we're adding type safety onto existing things. I think Python has a similar thing where it looks like Python and you add stuff to it. So yeah, okay. So now I can make a variable using let. I can say value colon and then the type, which is optional. You'll see that in a bit. And then I call a function and we're happy here. I can also make a function like I made the logging function before, where I just made a arrow function. So this is a function called adder, and then I have the arrow function notation, and then I just assigned it to adder, and then the body return a plus b. All right? And here you see that I don't specify the return type because they can deduce that. We can know what the return type is. Here I make a variable, I make it const, and I can, here I'm in Visual Studio Code, I can mouse over added value and it will tell me it's a const added value of type number because that's deduced from adder, which is then deduced from a plus b, and a plus b because it's number. So you can see this fun chaining happening. I can then also make a function. This is a bit more complicated. I have an adder or extra adder, takes in a number, and then a function, and then I have the arrow syntax. So instead of having the function, I say that the body is going to return a number, but otherwise it's the same. And then I can use that to say a plus func a. I can call the function and send in a function. And most of this stuff disappears then when you compile it. All right, then I have an interface. Let's say we have an interface called animal. And animals are cute, so I would like to know how cute the animal is. So there's a cuteness function, and that cuteness function returns a number. Good. And then I would like to implement a dog. A dog has a name and a certain cuteness amount. So here we have a regular class with some private members. Then I define that they are a string and a number. I then have a constructor. I can take in a name, but I also know that cute dogs are very cute. So that's a 10 out of 10. So no need to let me know how cute dogs are. So I can assign that there. So now we have the constructor here. And there's only one constructor. So don't worry there. Not the 700 that we have. And then here I have a function, which is then matching the interface. It is public by default, so if you don't say anything, it's public. And I would like to just return the cuteness amount. So it is 10 in this case. Okay, good. I can now create Steve, the dog, and I can log out how cute Steve is. Right? So I make a const Steve, new dog Steve, and then, yeah, Steve cuteness. Wonderful. But we can also do this. So cuteness is a function on Steve. So I can actually then store cuteness in a variable, and I can mouse over store cuteness, and it said the type of store cuteness is the arrow notation. So it's a function. It's a function that takes no arguments, returns a number. Okay, and then can I then call this function? No, I cannot. And the error says cannot reach property cuteness amount of undefined, because the this is lost in the context when I assigned it to a variable. So it's not like the lambdas where I can capture something and then it is stored within it. But there is a fix to this, which is instead of cuteness being a function, cuteness is now an arrow function. So this then goes around the other way, like I showed the example before, where if I had the arrow function, this isn't captured. But here it works, because this isn't a JavaScript class, this is a TypeScript class. So it behaves in that way. So now an arrow function behaves in the way that you want. There are other ways to get this to work, but they are weird and quirky. And I just want to show you this one because it's a simpler way. And now I can actually store the cuteness from Steve cuteness, that this is captured within store cuteness, and I can call it. No, that's fine. It works. So you can send a function from an instance into another function or into some system. So cool. We also have generics. So this line then looks for us like regular generics, right? Instead of saying template type name, we can just say T. And I have a T, A or B, but I return a number because maybe I want to sum up the cuteness. But that's not going to work. So we get an error here because we're asking for something within the interface. And T isn't defined to have anything in the interface. It is so generic it has nothing. So if I try to do this, try to add the cuteness of Steve to get the number 20, it doesn't work because property cuteness does not exist on type T because T is of type any. And any is a type which is basically used to help people get into TypeScript. Because they can, with all their JavaScript things, like they don't know the type, maybe not now, so they can just say, oh, the type is just any. So we don't know what it is. And then later on, they can change any out to something else. So that's very nice. So there's an any type, all right? So what I have to do is I have to say that T extends animal. So now, because we know T has a type, it extends animal, it works. And you might think, like, why don't I just then have animal instead of T? And you can, that's fine. But this comes into play a little bit later. But yeah, you have generics, but you need to specify what interface is happening here. And if you don't specify, you can still work with stuff, but you're very limited to what is within what you can do, because it has to be like very generic things, plus or get the length of an array or something very specific, all right? And then we don't want to have just one file, we want to have many files. So here I have animal TS, it's the same code before. Here I can also say public cuteness, even though it's implied, just to show you that I can do that. Cool. And then in some main file, I can say import animal dog from animal. I don't have to say .ts. So they're in the same folder. I can then make a Steve, and I can print out Steve. And maybe you can see that animal is maybe a slightly different color than dog, right? Because we don't use animal. So it's an unused definition. So we don't actually have to import it. And you can make it fail when that happens. So that's one of the compiler flags. You can say like, hey, don't let me do this. But you can. You can also do this. This is handy when importing from some JavaScript libraries or when there's a naming clash. So you're kind of namespacing the thing. So I can say, oh yeah, and I forgot to mention, there's an export. Oh, here we go, Neko. There's an export in front of the interface and the class, if you didn't notice that. That's where I'm getting it. So I can say import everything as animal, so whatever is exported here, I want that in the animal namespace, so now I have to say new animal.dog. There's also a way to default export, so if you don't say anything, you'll get it anyway, because that's always exported. That's useful sometimes as well. You might have seen that in the talk previously, he default exported everything. Cool, so, like I mentioned before, JavaScript is TypeScript, and TypeScript doesn't exist at runtime. So that means that there are no TypeScript-specific containers. And I put an asterisk because there's a couple of weird corner cases, but I'm not going to go into them. Because if there were TypeScript-specific containers, when you then converted them to JavaScript, you would have to have the implementation there of those containers in the JavaScript. You have to put them somewhere. Maybe there is no place to put them because it's used everywhere. So where should you put them? So maybe. So it's all JavaScript containers, but you have all of them, array, map, set, etc. But the difference from C++ is that the algorithms we know, they're within the container. So you can say, if I have the names of dogs, I have Steve, Solo, Max, and Buddy, and I know that I only want the short names. So I say dog names.filter, and I can send in an arrow notated function. It wants one argument, and I say return if name is less than 5. So then I get a new array of short names, and I only get Solo and Max. All right? Good. All right? Good stuff. So, are we on time? Good. Let's go into advanced TypeScript. Who's ready? So now we see, like, the language is generally fine. It's like has the features that you have. It's generally sane in that way. So things are behaving as we would expect. But let's take a tour of the type system. So TypeScript uses a thing called structural type system, or it's sometimes called type compatibility. I haven't seen that before, but I saw that in a few places. A TLDR of structural typing, and you'll see example, but if it looks like a duck and quacks like a duck, let's take that idea pretty literally. That's kind of a TLDR of what that means. TypeScript also sacrifices what's called soundness, and I can show you an example of that in a bit. But for those who are into type theory, know about that. So let's do examples. All right. So I have a fruit. A fruit has a weight in grams in a name. Great. I would like to make an orange. An orange has a weight 140 grams, and it's called a navel orange. Good. Also, I'd like to make an apple object. An apple object has 70. It has a name, Granny Smith, and it has a red color. And you can see that I haven't inherited anything. Right? So I have a function that says, takes a fruit and returns if it's heavier than 100 grams. Then I decide that it's a heavy fruit. All right? That's just what I have decided. But I can send in a new orange, and I can also send in apple. And that is because orange and apple satisfy the interface. That's similar to if you've written in Go. Go has something like that. So because orange has weight and apple has weight, and the only thing we need in is heavy is weight, we're happy. This is fine. I can even do this. Where fruit isn't a type, I make up a type on the spot. So I say, I want an object that has a weight of type number. So I just put that in. That's fine. Now I wouldn't need actually the interface. I can also save it. I make a fruit weight, which is a weight, and then I require fruit weight. So again, the interface isn't there because I know what I need. So that's pretty neat. Let's have more fun with this. Let's make an interface called name. There's a name, which is a string. And then I have an interface weight. So there are two different things. I can then AND them together to make fruit weight. So now fruit weight is an object, or an interface, if you want to think of it that way, that includes name and weight. So now we have a new thing that looks like the stuff from a previous slide. And I just made that up on the spot there. And I could have made that wherever. So now, my isHeavy function can take fruit weight. And I just used name as well to test that out, but you can see now it needs to have more than 100 grams and needs to have some text in its length. And I can even do this, fruit or weight. So now it's either a name or a weight. And where would that be useful? Well, let's again look at this. It's the same as before. I have a name and a weight. I have fruit weight, which is both name and weight, same as before. And now I have an is heavy. Maybe not the best name for it, but is heavy. It takes in fruit weight. But we return weight or null. All right? So we're either going to return a weight object or a null. And see what I'm doing here. I'm asking the same question, and if it fails, or it's the opposite flip of it, if it's less than or if it has an empty weight, I return null, or I return fruit. But notice what's happening here with fruit. Fruit was fruit weight when it came in, but it's weight when it came out. So I've narrowed the interface when it comes out, even though it's the same object, or even some other object. I could have sent in Granny Smith from before, which had a lot of other stuff, but I've narrowed, if you think of it, the view of within whatever this object is. Then I can send in orange, and I can send it in on the spot. Okay, make an object, because object is just a first-class citizen, if you think of it that way. So I sent it in as an orange, it has 200 in weight. So now is fruit is either weight or null, which matches with the is heavy definition, the return value. I can then check. If fruit is not null, I would like to print out the weight. So now the question becomes, what's the type of fruit within the scope? It's weight, because I have again narrowed what's happening here. I know that it's not going to be null. It was either weight or null. I did a check. Is it null? No, within the scope. So now within the scope, I've again narrowed that I know the thing I have here in my hands is weight and nothing else. And I could have sent in the Granny Smith thing from before, and it would still be fine. So I can mention soundness here because within this scope, I have guaranteed that it's not null, but there are ways for you to mess with this. You could have called the function and then also added another specifier to the type before you called console log. So you can mess with this. So it's not foolproof, but going through it like this, it's pretty neat that you can do this. Another thing is, a type doesn't have to be an abstract idea. It can actually be values, like an enum. And here, I have fruit names. I only want apples, oranges, or pears. So think of that as a type. This type is those three strings. So if we have the name is now going to be fruit names, not string, because I only want those. Same as before. I take in fruit weight, I return weight. But now when I'm creating the object there, I get an autocomplete. Because we know that the name can only be apple, orange, or pear. So we can have that strictness that, because we always have this idea that it's a string, it can be anything. How can you check it? But we know it's always going to be TCP or UTP, right? Or something. It's not going to be anything else. And generally it isn't anything else, so we might have some checks for it. But what if you say, like, no, it's going to be this thing and this thing alone. And if it's anything else, it's not going to work. Cool? So let's talk about const real quick. That's my time. Fine. So how it functions in TypeScript and JavaScript is a little different from C++. We have language features that will give us similar results, but they again also will behave differently. So this is probably the only example that will behave like we think it will behave, which is sad going forward, but learning const here, like this is, yeah, no, this is not going to work. Red squiggly, you can't change the value to something else. Good? So this is fine. Here I'm going to create a mountain, and the mountain has a height. Good. I'm going to create Everest, which is 8849 meters. Great. And then I would like to change the height of Everest. So even though I have a const Everest, I can still change the height. Because Everest, the mountain, is const. The height within the mountain is not const. So it doesn't propagate that way, if you think of it that way. Okay. What about arrays? And here I have a bunch of mountain heights and bonus points if you know the other two. So I have 8849 as the first one, and the array is const, not the values within the array. So I can change Everest back to 9,000. So that's not going to work because the array is const. I couldn't add the value to the array, but I can modify stuff within it. And the type of this is, it's an array of numbers. That's the type that's happening here. All right, so to change this, I have to say that the height within mountain is read-only. So now it will behave like you think. But we've now put that constraint that a height within a mountain is read-only on the type. So now mountain height is always read-only, which might make sense, but that's now a constraint you have, which you might not want to have. And this is the weird one. So you have const mountain heights, the array as const. All right, and now you can't change it. Because what's happening here is you don't have an array of numbers anymore. You have an array of a read-only set of these values and nothing else. So the type also changed, right? But that also means that if you use this, like we did with the oranges, and you use a different number, you say like, oh, we need the mountain heights. We need this type to go into the array, because these are the only mountains, and you put some other number, that's again going to fail, because we only have these types, all right? So, and then TypeScript has a collection of utility types. So these are generic classes that provide specific features. Most of these will take your type and then transform it in some way, do some fun stuff with it. So if we have the mountain, the name and the height, like before, and I want the height to be immutable and also the name, I can ask for a read-only mountain. But then again, that's another type. So mountain and read-only mountain are not the same. So now we have a read-only of mountain, if you think of it that way. So now when I want to change Everest, it doesn't work. Because what it did was, it took all the members that were there, which weren't read-only, and made them read-only. And there are more of these to make them optional or yeah, do other fun stuff with them. You can also do this. Let's say that you have a legacy system where the new type of user is some registered user, but you also have some old system where a user could be a string or a number or whatever. But then, so a user is either a registered user or the legacy user, which is string or number. So you have some backwards compatibility. But for some reason, the only valid user is a user without the legacy user. So you can actually remove it from user. So if someone changes things on the way, your thing is still valid, because if someone changes user or registered user or whatever, you just know that a valid user is whatever user said, but without the legacy. So in this case, it's only registered, but it could be more complex. So you've now removed a thing from the little pipe. All right? That's kind of neat. So let's do a more complex example. So this is actually, because I wanted to use the TypeScript documentation. This is from the documentation, from one of them. And I've removed some edge case checking to make it a nicer as a slide code. So let's say that there's a thing called an object descriptor that has an object called data of type D and an object of methods called M. And I would like to make an object. And I'm a templated function or generic function of D and M. I take in object descriptor, but I return a type of the combined D and M, whatever those two objects are. And again, think of objects as those curly braced objects. I just extract them, just so I have it nicer. And this is going to be some weird syntax, but I'll explain what it means. What this means is data is an object. It has some of those members like we had before, like the name and the weight and all that. And it will just expand that into, so I will get a new object, which is the curly brace after the return, that contains the members of data and methods. So I took those two objects and combined them, and just, they're two members of the same object. So if object A had members 1 and 2, and object B had members 3 and 4, this one has 1, 2, 3, 4. So I just combined them, all right? And I call that the D and M. So when I make object of these two separate objects, I have a new object of all of them. That's the only thing it's doing. So let's make that object. So I sent in an object that has data. Data is the x and y variables. That's D. D is then x and y. Methods M is just one function. Let's call it move by. That's the only thing it has. So on object, I can say object x is 10, object y is 20, object move by. So now I've taken these two separate objects, data and methods, and combined them into one. All right? So I have this function, I have this data, and this is useful if you provide the data in your library, but your users provide the functions. They write the functions on the data that you provided. So you can provide the data, make the methods thing empty, they can add methods. So that's kind of nice for that. All right? Okay, so let's implement move by, right? Good stuff. This dot, it doesn't work. Because if I say this dot, I only get move by. I don't get x and y. And you might think, but wait, we're combining them. Well, not yet. This is before make object is called. So we're still outside of all this. The methods is type M. So since method is type M, we don't have access to members in type D yet. So there's a feature for this. So that's one of the utility types. You can say that if you look at line 3, method is M and this type of M and D. That's another utility one. So now when you say this dot, you have access to all of them because the type of this is no longer whatever it was by before. It is M and D. So you can play with this stuff. So now I can go and implement move by. Fancy. I want to have one fancy one according to all the small ones. All right, good. So, second to last thing, there's a lot of JavaScript libraries out there. As you saw that this environment has been here for a while. They can be installed with NPM and used with TypeScript, but TypeScript also wants to let you use these libraries safely. So there's a thing called TypeScript declaration file, .d.ts. So what this is basically like a header file, if you think of it like that. It's a header file for something else. That's a nicest way to explain it to you. All right? So if I have a JavaScript, so this is now just a JavaScript file. I have getCuteness, I have animal.cuteness. There's no type safety, we have no idea what's going on here. And JavaScript is completely happy with this. This exports dots. This is one way of exporting a function. There are many other ways, but this was kind of the simplest one to show you. So there's an exports object. I make a member called getCuteness, and I say that that's the same function. So it's kind of a weird, there's like this exports thing, and then I'm just attaching it to it. All right? And then I create a d.ts, where I create the interface like I did before, and I create the function header. And I say, you can send in an animal, and it will return a number. What it does, we don't know. But here's a function. So now, in my TypeScript file, I can import animal and getCuteness from cuteness. So you see, I'm not importing it from the DTS, I'm importing it from the JavaScript file. And I'm getting the types exported out. It's actually mixing the both and doing some fun things, which is why you don't say .ts or .das after that. So there's some magic that's happening here. But now I can make Steve, it's no longer a function, I just made it a variable. It has a value t. And now if I mouse over getCuteness, which in my brain is the JavaScript function, I get the full type safe thing. And if I do it wrong, it will warn me. Say like, hey, you're doing this wrong. So someone that has a well-known big JavaScript library, they can give you a DTS file, and now you have a type-safe interface towards that library. And there's actually a project called Definitely Typed on GitHub. And the only thing it has is just nothing but d.ts files. And you can do an npm install. So if you install, like, let's say a MySQL library, you can then install the types for the MySQL library. And some of them will actually come with the DTS files. So now you have this existing set of libraries that you can also be type safe on top of, which is pretty nice. Okay, let me see the time. Wonderful. So, summary, we've gone over the history of JavaScript. We looked at the environment and the problems that exist with the language before. We've seen what problems TypeScript is trying to solve. Again, that's not perfect, but they're trying their best. We've seen TypeScript features like classes and functions. Gone over const and some utility types. Looked at structural type systems and declaration files. Good. But, so let's think about this for a minute. We have an old standards-driven language that has perceived complexity and quirks. Attempts to fix it with other languages or static analysis. An immense backlog of libraries and backward compatibility concerns. Headers towards old languages to increase the safety and allow usage of libraries from the old language. And the old language has features that are not well desired in the new language. So methods are used to replace them with other features or options or even abilities to turn them off. Does this sound familiar to a couple of people here? They go, no, not us, right? They even have their own Godbolt, Compiler Explorer. So on their website, you can just type in TypeScript and you'll get the output out just to see what's happening. They're doing the same thing there as well. Yes. So, this talk was a trick. C++ can actually learn a lot from what's happening here. Not only with regards to the relationship with C, like you thought of it, but going forwards as well. So, we have changed a lot in the past. Like we have tried to improve. We've improved our tooling and helped to add features to remove many of the quirks. But the quirks are still there. And they're probably not going to go away, right? So imagine another language, let's call it C+2 or something, where you would write a language that is then turned into C++, right? Or even just enhanced static analysis that would do this for you. So you could then turn off certain language features or structure the language where old idiomatic behaviors wouldn't be there anymore. So it's just an idea, right? Imagine if you could turn off initializer lists, right? They're just not there. They don't work. They don't do the thing you do. But then you would just get C++ out, right? Food for thought. This is me. Please yell at me on Twitter. Thank you. Questions, comments, thoughts, TED Talks? Wow, was that clear? All right, thank you.
That's a quick question.
Yeah, go for it.
In what situation would you say TypeScript as a language excels other languages?
It's languages that have to then target the JavaScript runtime environment, because that's kind of what TypeScript is focusing on. Yeah, that's a tricky question. I would have to think about that more, because there are features, because the main issue here is that the language is kind of bound to this other language, like with C and C++. So we have to inherit their quirks and then behaviors. So TypeScript is kind of, the negative side of it is that, but then the benefit is all this extra nicety. So I would actually say, I don't know then. Yeah.
So maybe you have a library of TypeScript or JavaScript you want to run, then TypeScript is what you're going for.
Yeah. The idea is that what if you have a library JavaScript or TypeScript, I would, if I'm working within this environment, if I'm making web pages, or in some cases, pretty lightweight servers, I would always grab towards TypeScript because you get the benefits of both. Some people are purists and want to go to JavaScript, but that's fine. I would always tend towards TypeScript, and I think it's pretty nice. There's a thing that I haven't covered, which you might not know about JavaScript. JavaScript is single-threaded, mostly. There is a thing to do. There's a way to do multi-threaded, but that's within Node.js. So the whole language is single-threaded, so the whole locking and all that stuff doesn't happen. But you still have async and promises pretty well supported in the language. So you can actually just write an async function to do something, and then somewhere else you could just say await and get the value, and there's no cost, which is like I want. in C++, but maybe we won't get there. Fair? All good? Then have a lovely day.